All right, welcome this morning, everyone. My name is Jason Vandiver, Energy Code Program Manager for SPEAR. Welcome to our SPEAR Speakers Bureau. This is a SECO HVAC specific webinar series. Breathe easier with high performance HVAC sealants and coatings. Our speaker this morning is Frank Forrest with Hardcast, a Carlisle company. Frank is the Efficiency Solutions Product Manager at Carlisle HVAC. Since 1965, Carlisle HVAC Products has provided high-performance solutions for HVAC industry, manufacturing rolled duct sealants, mastics, adhesives, coatings, hardware, as well as other accessories. Carlisle products encompass hardcast, duct sealants and adhesive, Dynair airflow hardware, the Nexus 4-bolt flange closure system, Spray Seal, which was the first sprayable duct sealant, the Isaac, the inspection sealing and advanced cleaning robot. Ooh, that sounds pretty fancy. Carlisle HVAC is passionate about energy efficiency and focused on continuing to pioneer solutions to assist the industry in meeting these goals. With over 13 years in the HVAC industry, this aligns perfectly with Frank's passion about the HVAC system efficiency. I know I can speak personally for Frank. I certainly appreciate him being a champion for SPEAR and the efforts and work that we do. I know that he believes in what we do, and he's a great person to hang out and have a conversation with. One of the folks that I like having beers with just about everybody, but Frank ranks up there at the top. Those of you that don't know about SPEAR, we're an regional energy efficiency organization. We cover Texas and Oklahoma. Any way I can help you guys out, the price is almost always right because it's almost always free. Whether it be field training of your inspectors, QA, QC of your third-party energy inspections, coming and training the plan review staff, energy code questions, whatever it may be, don't hesitate to ask. I'm happy to help you out. You will get my contact information with the follow-up email, just some housekeeping notes. We are an ICC preferred provider. So you will get ICCCUs if you answer the questionnaire that Liz will send out to you after the webinar. And for you inspectors, I know this is in Spanish. I made this slide for all my insulation installers. I teach a insulation installation class. I'm also doing a HVAC residential installation class, energy code classes. I've got about 30 or 40 different presentations I'm happy to give whenever you need. I just signed up. I'll be doing, May 13th at BPI in Irving. I'm doing a full day, 3 hours residential, 3 hours commercial. But those of you that don't speak Spanish, we have a lot of inspectors and raters on the webinar today. And what I want to do with this slide is just thank you for the job you guys do, and really let you know to not underestimate the job you guys do. $20 a month might not matter to me. That's just a little bit less beer money. But a single mom or little old couple on a fixed income trying to afford prescriptions, that $20 or $30 a month that their utility bill, could be more than it should be, because we didn't make them seal their ducts well, or we didn't make them insulate the wall. We gave them a green tag when we know we should have given them a red tag on an insulation job. Don't underestimate the job you guys do. It is really important, and thank you for doing it. And with that, let me switch over to Frank's slides, and I'll be advancing his slides. We had a little bit of a technical difficulty this morning, but no worries. I'll just advance his slides and we'll get started. Frank, you go ahead and let's make sure we can hear you.
All right. Can you hear me? Everything's good?
Yep.
All right, good. Thank you. I appreciate the introduction, and I also agree you're a lot of fun to hang out with and have beers with too. So,
Thanks.
But the presentation I'm going to give you this morning is a slightly slimmed down version of an AIA presentation. I understand we will probably have architects, engineers, contractors, and code inspectors on here. So there's a little bit of something in here for everybody. So on the next slide, really what we're talking about is there's a lot of course description here, but basically we're going to talk about sealants, the different kinds, key things that you need to be looking for, how to properly install those products, and also some of the key focuses for the industry. So there's an introduction slide. If you would go to the one with the Ferrari, that would help. Thank you. So kind of interesting analogy, but when you see a Ferrari, you notice the beautiful sleek body style, immediately equate its appearance with speed. Under the hood of the car, you're thinking there's a nice big gleaming engine that's designed for superior performance at high speeds. What we often take for granted, though, are all the seemingly small but necessary components that make the car perform as expected. Without gas or even oil, that Ferrari would just be really kind of a shell that looked pretty, but couldn't do what it needed to do. And believe it or not, that same theory applies to high efficiency HVAC systems, right? A building may have the latest, newest unit, but without the necessary components like properly designed ductwork, properly sealed ductwork, those kind of things, the unit will fail to perform as expected and could lead to negative impacts on the environment, indoor air quality, the people, and really more key specifically is the indoor air quality and that impact on the people. Jason touched on that with, an older couple or whatnot, where we maybe green tagged something that we maybe shouldn't have. So next. So everyone knows what HVAC is. We're distributing conditioned air throughout the building. The return ducts will take air in to be reconditioned, recirculated. We know that there are a plethora of codes for install, design, build, test, and all that. And we know that they're typically constructed of sheet metal, flexible duct, and duct board. And I think we can all agree that probably in Texas, a lot more flexible than some metal in the residential specifically. So we're going to move on and talk about why sealing ductwork is critical to maximize an indoor air quality and your HVAC system efficiency. Next slide. When a duct system leaks, for one, it reduces your system capacity and it decreases the life of the HVAC unit. This is easily understandable as the system has to run longer and more often to meet the comfort needs. Duct leakage creates hot and cold spots, right? Inconsistent heating and cooling areas. Creates humidity control problems, which, Houston is a good example of that. And those, of course, all that affects the thermal comfort of the occupants and can have negative impacts on the indoor environment. Additionally, when ducts leak, more energy is used. If the system's running harder, running longer, it increases your utility costs. And as we all know, the cost savings have been the traditional focus for sealing in the past. And we're going to kind of come back to that. When we look at electricity consumption by sector, we can see that over 77%, almost over 3/4, goes just to operate the buildings that we live in and work in and every day. And by comparison, industry uses 23 and transportation less than 1. And if you look at that 77% for buildings, lighting used to be the major consumption, but that has shifted due to LEDs and the cost of LEDs coming down. Also, LEDs, lighting, and those kind of things tend to be, low-hanging fruit. So now, when you look at this consumption for building energy, you're going to see that the comfort system, your HVAC system, heating, cooling, and ventilation are going to be the lion's share of that pie. All right, impacts of duct leakage. We know that all ducts have some degree of air leakage. We're not plumbers, and we would like to be eventually someday. But anyways, getting leakage down to a reasonable level is possible by using a good sealant and actually having the contractor, installing contractor, trained on some of the key things about a proper application. When you look at equipment ratings, if you're looking at a rooftop unit, those equipment ratings can pretty much be kind of meaningless if you have a poorly designed HVAC duct system and it hasn't been sealed appropriately. So Lawrence Berkeley National Lab did some testing and came back and said that if you had 6% of duct leakage, it reduces your EER by 7% and your SEER by 14%. By the time you get up to 30% duct leakage, it reduces your EER by 36% and your SEER by 42%. And when you look at some of the data, Um, Typically, a residential home, back when LBL&L did this testing, was leaking on the range average of 25 to 30%. So, you know, when you have a really nice big SEER unit sitting outside of your house and you have ductwork that's not sealed, you have some system effect issues and all that, you're just really not getting the benefit of that equipment. So energy loss, as we're, you know, running that SEER at the unit at such a lower level SEER, it's basically money being thrown out the window. An example was a few years back, there was some data shown that commercial buildings are losing roughly $2 billion a year in energy loss just through leaky ductwork. It's a huge amount. You know, measurements reveal that light commercial buildings tend to have significantly higher duct leakage rates than large commercial buildings. Light commercial buildings typically are not commissioned, so duct leakage problems are not identified and fixed. In addition, smaller commercial building projects also may not involve an HVAC design engineer and are more focused on minimizing first costs, which can lead to inferior construction practices. And the manufacturing facility I work out of is a manufacturing facility with an office space added onto it, and we all run into this. We have issues with that here in our own building. Also, a major source of energy loss in residential buildings. You know, most duct leakage actually occurs at the connections to registers, plenums, and or branch lines. So next slide. So efficiency in regard to costs, dollars, you know, going out the window, that kind of stuff, that's traditionally been the focus. You know, however, the real issue and the bigger issue is indoor air quality. You know, we all know the HVAC system significantly improves your indoor air quality, and the more efficient it is, the purer the indoor air. Effective duct sealing significantly improves your indoor air quality by removing heating and cooling inconsistencies and giving proper humidity control throughout a building. These hot and cold spots and under or over humidity account for the biggest complaints of facility managers. Effective duct sealing, thus impacting your indoor air quality, can contribute directly to LEED credits, specifically IEQ 7.1, which is thermal comfort, and 7.2, which is thermal comfort verification. Interestingly enough, to get the 7.2 LEED credit, only 80% of the people have to be happy with the conditions in the building space. But we all know that 20% that are not happy are going to be the ones that are the loudest about their concerns. I think I'm not sure if that video will play for you, Jason, but it may not. Okay. Basically, from you know, the Christmas movie Nakatomi Towers, come down to the coast, get together, we'll have a few laughs, showing Mr. Bruce Willis and the duct system. Just a little humor, but we don't really live in the ductwork, but the ductwork is the conveyance medium for the air in the buildings we do live in and work in every day. So we are surrounded by it and we're breathing it, and whatever is in there is what we're handling.
Yeah, sorry I couldn't get your video to go. We'll make sure and get it next time.
No worries.
Well, hold on.
All right, so you know, when we're talking about breathe easier with a clear conscience, right? Return leaks, we all know that can pull outside air, hot in the summer, cold in the winter, into the duct system, reducing both your efficiency and your capacity. Leaks in the return ductwork draw air into the building from crawl spaces, garages, attics, above ceiling grids, bringing with it dust, mold spores, insulation fibers, and any other contaminants that are up there. You know, over or under pressurization from duct leaks and imbalanced duct systems can cause spillage of combustion products, for example, furnaces, water heaters, fireplaces, into the building. It can also negatively impact critical rooms such as surgery suites that we all know must remain in a slight positive pressure state to keep any potentially harmful bacteria or debris from coming into the surgery suite. Lack of humidity control can also impact occupant safety. Too much humidity and mold can proliferate. In humid climates, you know, moist air is being drawn into the return leaks and can overwhelm the dehumidification capacity of the air conditioning system, causing buildings to feel clammy even when the air conditioner is running. Next. So typically leakage with HVAC systems is due to the air leaks at the joints, seams, and fittings. And as you can see in these two pictures, on the left we see duct leakage at a slip and drive. seams by evidence of that black residue. We also see energy loss at the seams of the spiral duct on the right. And that could be either a positive pressure leak or negative pressure leak, creating turbulence around that area, pulling any dirt and debris out of the air and depositing it on the surface, or if the duct system internally is dirty as well, could be pushing some of that debris out of the duct system. Next. So the solution, of course, is specifying a quality duct sealant or a coating if you're going to be using that. And really, you know, it must be specified during the design stage. I'm going to talk a little bit about existing buildings and restoration style too, but from the new construction side, you know, it really needs to be specified during the design stage. You know, the goal with this is using a sealant, on joints, seams, wall penetrations, you know, any fittings for that may be tied into the duct system, you know, meeting the required building codes, ensuring that the right duct sealant products are used in the building to protect the building occupants against long-term emissions as well. And I'll talk a little bit more about that as we go through. So results of using a quality sealant or a coating is going to optimize your system, indoor air quality, and your system efficiency. It's sealing properly and tightly on new construction, repairing and sealing air leaks on existing buildings. Sealing leaks in the system is one of the best IAQ practices, which saves cooling, heating, and fan energy. It reduces the load the fan must handle to deliver the same amount of air to the conditioned space. And once again, these are all promote comfort for building occupants and healthy indoor air quality. And once again, if this is plumbing leaking water, it's a no-brainer. You got to fix the system. A lot of times the ductwork is out of sight, not seen. And if there is leakage, we don't really know that, but we do know the comfort issues. And a factor in keeping the office or living space safe and energy efficient is also maintaining clean air ducts. Sealing appropriately, make sure return air is not pulling in contaminants such as fungal spores, damp air, hazardous fumes. And keep in mind that mastics must have microbial inhibiting properties and long-term performance. The goal is to seal that system, and preferably for the life of that system, and making sure that whatever you do seal that system with is not going to add to any particular growth if there's any debris or water that gets into that system. And it should never, the sealant product itself should never become a food source for microbial growth. And that's just one of the key things. All right, so we'll talk about the different types of sealants. There's several options to choose from when selecting a duct sealant, depending on the size of the project and the time commitment it will take. Mastic comes in typically water-based and solvent-based and can be either brushed on, or sprayed on. And another option is to use 100% solids product known as a rolled mastic sealant. It looks similar to duct tape, but make no mistake, there is no comparison. If you put a piece of duct tape down, you can peel it up and put it back in the right spot. If you put a piece of rolled mastic sealant down on the wrong spot, you need to squeegee that down and cut you another piece. But once the sealant's applied to the surface, the squeegee is used to ensure all of the air bubbles and the wrinkles are taken out of that on the install to make sure that you're not getting any air leaks or potential for water coming in. And then, of course, another choice would be in a caulking tube. And there also is caulking available in silicone form as well. And as you can imagine, it's applied with a caulking gun. So environmental advantages. Some of the things, mastic sealants have enhanced performance for higher SMACNA pressure classes, rated pressure classes up to 10 inches of water gauge. And in a lot of cases, what you'll find is that there is a slight safety factor built into the SMACNA guidelines, and you need to be able to go up to 15 inches of water gauge. UL listed is absolutely key to verify the product will perform specifically for flame and smoke data, in addition to the mildew resistance and many additional tests. There is LEED criteria V4 chamber testing, which is tested for emissions once cured. There is also a newer thing called UL 2818, known as Green Guard, and that is also a test for emissions once cured. So it sounds like the V4 and the Green Guard are the same. However, that LEED V4 chamber test is just a once and done test. and it looks at around a total of 32 chemicals for emissions of those. When we're talking about Green Guard, you have Green Guard and Green Guard Gold. Green Guard is a continuous certification process where you have to re-verify each year, and I can tell you it's not inexpensive. If you get Green Guard Gold certification, they have tested for the emissions of over 12,000 chemicals. So there is a huge difference there. Lead V4 I can do once and done and put it in marketing paperwork for the next 10 years, where a Green Guard certification is something that's going to require a yearly review and re-verify and retesting. We talked about the LEED credits for indoor environment quality, the IEQ credits. There are also credits for low VOC and local sourcing. And, you know, the sealants should meet those requirements and allow you to apply for those credits. Many additional requirements also under ASHRAE and ASTM. And then, you know, these are really just all key to understand. For example, there's an aerosolized adhesive product that does not actually meet the UL and SMACNA requirements and can leave a residual tack in the duct system, which, if you think about it from an indoor quality side, is probably not a good practice. So it's basically at the end of this slide talking about really pay attention to what you're specifying. All right, moving on. Thank you. So a liquid mastic, some of the characteristics and advantages. You know, if you're looking at a liquid mastic, it's easy application, it's continuous coverage, it's really good for compound angles. Typically you have UV rating on those, so they can be used indoor and outdoor. Have a wide service temperature range of, you know, -20 to 200 degrees Fahrenheit. Rated to pressure classes up to 16 inches of water gauge. I know for our company in particular, we do third-party testing of that. They're typically a high viscosity, so they're nice and thick, easy to put on the duct and stay in place. There's also a white, you know, it's offered in two great colors, white or gray, or some version of gray. And it cures to a non-tack flexible surface. If we're talking about liquid mastics, the brushed options, you have a scrim reinforced, which would be what we call just a reinforced bucket and brush, or pookie, as you might call it. What that is it has fibers within the sealant, mixed within the sealant, that helps to help bind it better over gaps or voids. Reinforced mastic is always water-based, can only be used for sheet metal and ductboard applications with a scrim, and meets both UL 181A to M and UL 181B to M. Non-reinforced mastic is either water-based or solvent-based and is used for flex duct and sheet metal, and it also meets 181B to M. There's also sprayable, spray-applied duct sealants, which when you're looking at a sprayed product, of course, it's always going to be non-reinforced. That means there's not going to be any fibers in there to get into your spray pump and cause any clogs. And it's used for flex duct and sheet metal, always water-based, low VOC, and meets the UL 181B to M. And spray-applied is the fastest application and consistent all day long, as you have a pump that's doing that work, mainly the majority of that work for you. Moving on to rolled mastic sealants. They have the following characteristics. They are UL listed, typically UL 181 BFX. They are rated up to 30 inches of water gauge. And that's actually the way we test that is over a 1-inch diameter hole at 30 plus inches of water gauge for a solid 24 hours. Meets all seal classes then, SMACNA A, B, and C. Use it for flex duct and sheet metal. It is the only true zero VOC duct sealant that's in the market because it's 100% solids. It's fully cured when you get it, actually when it comes off of the equipment. Ideal for replacement, change out applications. It's very easy to use. You can use it indoors or outdoors. Has excellent UV resistance because it has a foil facer. Typically 2 mils of foil and about 17 mils of butyl. And then we have a thicker version as well that goes actually up to 30 mils. One of the key things with this type of a product is it is actually a waterproof seal as well. So it can be used in below grade applications. If it's used on ductwork on a roof and you have some ponding water on top of a duct system, you don't have to worry about that water getting through this sealant. So rolled mastic sealants have many other characteristics as well. Since they're 100% solids, there is no off-gassing. They're mildew resistant. They're uniform thickness, so make sure you have a good homogeneous and consistent install. They offer good elongation, excellent tensile strength, and a really wide service temperature range, -20 to 200 Fahrenheit. Flexible, it's an instant bond and seal, which allows the system to be tested and or turned back on immediately. And the facer with consistent mill thickness gives a clean and consistent installation that can also be painted for exposed applications. So indoor air quality is especially important in such venues as hospitals and schools where compromised people and children are at risk of being exposed to harmful bacteria and viruses. In hospitals and schools, sealants should provide a surface that is resistant to mold and bacteria growth. They should have no off-gassing once cured and minimal VOC content when in the liquid state. Sealants that are flexible and can move with the duct system gives long-term integrity of the HVAC duct system. So you need to look for sealants and mastics, both water-based and solvent-based, that are below the LEED limit, qualify for LEED credit contribution, and under the requirements for the South Coast Air Quality Management District. Let's talk a little bit about quality control and manufacturing. As you can see there on this slide, there is a plethora of items to be tested, verified, and recertified when manufacturing a quality product. On the next slide, just an example here is raw material verification. The picture shows a raw material being run through an IR scan, and that's being done to verify that the contents of that product meet the purchasing specification. We define, when we're talking about polymers and those kind of things, we define a very specific range of ideal components within that, and make sure that we verify that that meets those components, meets the specification, excuse me. Also, additional quality control checks should verify the viscosity, making sure that it is the appropriate thickness. You don't want to get out in the field and put some on there and it doesn't spread, or it spreads too easy and maybe drips off of the duct system. Making sure that the pH level is right. pH level can really be tied into viscosity. Verifying the density is correct, the percent solids is correct, and then just making sure it falls within the type manufacturing specifications. In addition, a 90-degree mandrel bend test will show the flexibility and adhesion to the substrate. In the middle picture, what you're seeing is the after result of a mandrel bend test. The product is applied to a piece of galvanized at the specified mill thickness. It's left to cure for a full 48 hours, and then you literally take that galvanized piece and fold it in half. And it's such a great visual for elongation, flexibility, making sure that there's no cracking. Every manufacturer utilizes a source should have retains of the product manufactured in the facility for a minimum of 1 year. Typically, it's going to be in line with the shelf life. And a retain is the exact same product that you have in the field in your hand. There's a batch code that's tied to the product, and that way, if an issue does arise in the field, it lets the manufacturer retest the exact product that you're using in the field, and then it can help narrow down where the issue lies, whether that there is an issue with the actual product, maybe there's an installation issue, maybe temperature, humidity, maybe there's a substrate issue, or maybe even some improper preparation. Basically, having that retain and you run into an issue, reaching back out to that manufacturer, they should be able to give you peace of mind and help you determine exactly what's going on. So results of unchecked poor manufacturing, is just ensuring indoor air quality, right? Being aware of what is in the product that is intended for the use. To prevent mold growth, you need to look for sealants and mastics that do have some VOCs. And those VOCs are going to be added as a fungicide, which is actually also required by the UL 181 requirements when you're talking about a UL listed product. And note that some VOCs are required to keep the product from freezing and potentially becoming unusable. Not something we really have to deal with much in Texas and Oklahoma, except for maybe last weekend, which was crazy. But, this way the user will still be able to use the product during the winter months, not have to worry about mold growth on the mastic, or in the pail prior to application or after it's been applied. So this picture to the right shows mold growth in a bucket, and that should not occur with a UL 181 listed product.
Yeah, last weekend was a perfect summary of Texas weather.
Exactly. So recommendations for the installers. Another factor to ensure quality controls, the installer should verify that the shelf life has not been exceeded. Often 1 year, some manufacturers will be less, sometimes only 6 months. In addition, we talked about the lot number or the batch number. All Mastic products should be labeled with a lot number or a batch code to ensure that those key physical properties of each batch meets the published specifications. That lot number will tie back to the retains we talked about. So let's talk about some installation criteria for the sealants. You know, it's key to utilize specifications to define your requirements of product performance, specific needs, testing protocol, etc. Here's just a couple examples of sealant specifications. When we're talking about transverse joints, next slide, we know the transverse joints must be sealed once they're assembled on the job site, right? In the left picture, the gasket is shown following a nice radius around that corner. Ideally, applying the sealant with a loop in the corners and tucking it over helps seal those corners appropriately. Most 4-bolt flange manufacturers and most shops that manufacture these cut back that corner to make that easier to install, and that tends to be a very specific leaking point. If the shops you work with, or if you're sealing, putting the transverse joints together on the job site, making sure you take that butyl gasket or that EPDM gasket, whichever you're using, and looping that in that corner can help seal that, make your sealing after that much easier. Longitudinally, typically a Pittsburgh lock or a snap lock should have a sealant shown here in the green in the pocket, which then seals the longitudinal seam once it is snapped together. Now that doesn't mean the longitudinal seam is fully sealed, as at the end of the duct section, it is straight cut, and that can allow an air pathway where you can see leakage along the longitudinal, right, as air is always looking for that path of least resistance. So in that center picture where you see the green, we would suggest that you seal on the top and even on the side because of that end cut where air can come back around. Where to seal flex duct, right? In the picture, you see the technician applying mastic around the flex duct using the brush technique. Typically you're going to apply that, zip tie that, then pull the cover over. When you're talking about air handlers, make sure to check around the plenums and apply mastic to any seams or joints to ensure proper sealing. Pay attention though to access openings, doors, and service panels. Most of those should have some sealer gasket already. I get asked all the time, can I use your rolled sealant on an access door? Not a good idea. It's not something you're going to be able to easily remove. But when testing, that's something to pay attention to as well, is looking at that equipment around those access openings, those service panels and stuff, to see if that's where you're getting some of the leaks from too. Other connections, right? If you're talking about boots, T's, Y's, registers, plenums, you got the pictures here with the green showing where you should seal. It's just important, when you're looking at residential, or when you're looking at, typically residential, you get a lot of your leakage is going to be at the registers. You're going to get leakage in the plenums, the branches, and even the duct wall penetrations too. Let's see will that video play for you? No? Okay. There's a video that was actually going to show how to install brush, sprayed, and then a combo system. And what I can do is talk about it really quick. On a brush applied, right? The brush applied is typically the...
I can't get it to play. Sorry.
Okay, no worries, no worries. So on a brush applied, right, it's typically in the hands of the person that has the brush, and how they're actually putting that into that joint or seam, how much they're pushing into there. And depending on, typically I think it's usually the newest guy on the job site. You give a bucket, you give him a brush, you tell him, hey, go seal that. So just paying attention to make sure that they're getting all the joints and the seams, and applying it with as much pressure as they can. Pardon me. When we're talking about a spray applied, that takes a lot of that out. And what you'll find on a spray applied is you're spraying, typically it's an airless paint sprayer that's slightly modified to spray a duct sealant. And you're spraying at a pressure of 15 to 1800 PSI. And at 15 to 1800 PSI, when you're going into that joint or seam, you're actually driving that sealant into that joint or seam at high pressure. So if you're talking about spray applied, you'll get a better seal than typically you will with a bucket and brush. And a combo system is kind of a belt and suspenders approach, if you will. Typically on outdoor ductwork, you would use a bucket and brush or a spray applied to go around all the joints and the seams and the longitudinals. And then once that product is cured, you would apply a rolled mastic sealant over that, which would have a 1/2 inch on either side that allows it to adhere to the surface. The goal with that is just making sure that your, you know, the rolled sealant with the foil facer gives the UV, long-term UV protection to that sealant. And that's something as a company for us, we actually offer a 10-year warranty on that. On the rolled mastic installation, another video, but that's not going to work, no worries. On that one, it's basically, you know, tearing or cutting the piece of rolled mastic sealant you need, removing the release liner, applying that over that surface, and then key is making sure that you use a squeegee, a plastic squeegee to apply it. That gets you your full adhesion, removes any air pockets, any air channels to make sure that you have a great seal.
Now,
All right,
now
next
when
picture.
when they're working on drywall in the adjacent room and you've got drywall dust all over everything, probably cleaning that surface prior to rolling the tape would be crucial, or will it just stick right over anything?
Well, you know, what I would say in that situation, you're right. Cleaning is definitely key. Honestly, taking a you know, a rag or something like that to wipe the majority of that off. You don't need to get in there and, you know, take a, you know, mineral spirits or something like that to wipe the surface. Just wipe the excess dust off and then squeegee down over that. Yeah, good question. All right, so in this picture, the rolled mastics were used at the joints to prevent air leakage, and you can see the product install gives a very clean look, and then in the end it was painted to match. And then next one, we talked about rolled mastic being used underground and subgrade applications. You know, it's key because you have no dry time. It's naturally resistant to termite and bugs, and it is waterproof and offers excellent adhesion to PVC. So it's important, though, that you use 2 to 3 layers of the rolled mastic sealant in a subgrade. And really the why is the initial layer seals for your air leakage and waterproofs the joint. The second and possibly third layer is considered your protective barrier. Just make sure that you're protecting that initial layer when that area gets backfilled. So let's talk about some installation criteria for interior applications. There's section 233-100, which are duct sealant mastic specifications. Just like you have specifications for exterior sealing, there are specification requirements for interior or the air side. The air side should have full detail on the safety of the product and emissions once cured due to the additional exposure through the building. Section 230-130, antimicrobial coating. These specifications are related to products that are used to coat fiberglass. You know, the coating locks down the friable liner, so an existing building that has fiberglass insulation in the duct system and you're getting particles, material coming out of the duct system, you can go in, do a actual duct cleaning, and then coat over that, lock down those fibers, and keep those from getting back into the airstream. It gives you a much cleaner system. Also, not only do we do you know, use sealants and coatings on the inside and outside of the system, but we also use coatings and liners within the air handlers. For example, condensate drain pans as well. Just an example of a specification and performance data for a pan lining product. One of the key things that we've seen there is making sure that you have ASTM 84 flame and smoke rating on a pan lining product. If you're coating a drain pan, restoring a drain pan, you want to make sure that you're using a product that does not add to flame and smoke if there was ever an issue down the road. Liability. All right, that's the last video. We know it won't work, but basically what this is a quick video from NADCA. It's talking about this. It's a mother and a little boy, and the mother is always severely focused on whether there's any nut product, any nut products within anything he's trying to eat. But when it comes to your home, there's really no attention paid to the cleanliness of the duct system. And as we all know, next slide, there is a large group called NADCA, the National Association of Duct Cleaners, that do duct cleaning. And it's kind of key that if you're going to do any kind of interior restoration or any kind of interior work on a duct system, ideally you should get it cleaned. Here you can just see a small sampling of some of the brushing, air whipping, collection tools that are used to clean ductwork. And once again, there's a whole industry of NADCA that's focused on that. A lot of cases they will use a HEPA contact vac, to where they physically vacuum that surface of the duct system to remove any of the items there. And on this slide, just a couple of other things. You can roll the products on, you can spray the products on. Kind of in the middle of the screen, you're seeing a cart assembly that can be sent down a duct system. And on the left side of the screen is the robotic system that Jason talked about in the introduction. All right, so let's talk about verification of indoor air quality, which is also tied directly to your duct leakage testing. To ensure quality control, the designer needs to specify the duct pressure class or classes required for duct construction. In addition, they should match the fan to the system pressure losses, account for equipment leakage, which includes fans, coils, the VAV, etc. They also need to identify the seal class and indicate the amount and manner of leakage testing. And this is where the designer would add to their specification any particular requirements, such as UL 2818 tested and certified for emission levels. And this is one of those kind of things where we get to this point, it's kind of one of that, you already did this, right? It's already laid out and defined in the specs. So standard duct sealant requirements, SMACNA has their table 1-2 shows the different seal class A, B, and C, C being transverse joints only, B being transverse joints, longitudinal seams, and seal class A being all transverse joints, longitudinal seams, and any duct wall penetrations. The requirements for that are for class A are 4 inches of water gauge and up. However, what we've been seeing, and you probably have been seeing as well, is even in low pressure duct systems, they want a seal class A. With the focus on indoor air quality and SMACNA's role in this, they're tightening those specifications. On that next slide, you can actually see this. It's just showing the applicable seal classes for rectangular and round metal ducts. And you can note the changes. For example, under transverse joints only rectangular metal, it's changed from 24 to 16. And the 24 means you're allowed to leak 24 CFM of air for every 100 square feet of duct surface area. And that's been brought down to 16. And you can see SMACNA is starting to tighten up their requirements as well. Next one's the SMACNA Air Leakage Test Manual. That is the guideline for how you will test. And that is tied in along with International Energy Conservation Code, the International Green Construction Code, and IATMO's Green Plumbing and Mechanical Code. And then ASHRAE 90.1, what's kind of interesting about ASHRAE 90.1 is it wasn't until ASHRAE 90.1 2010 that we required duct leakage testing on new construction. It is only 25% representative sample of the system, but it's amazing that it wasn't until 2010 we decided to really start testing and making sure the duct system was sealed. So as we talked about, IECC, IGCC, and IATMO all use similar equations and guidelines for testing. So when you're doing a pressure test, when you're looking at this, you're going to do a leakage test for the duct system, typically constructed to 3 inches of water gauge or above, 3 inches of water gauge or lower. Typically not testing, but it's still recommended per the SMACNA guidelines. What we're seeing out in the industry is that you're testing everything. And then if so, the designer must clearly designate in their documents the portion of the system to be tested, and they must specify the appropriate test methods. Just a reminder that a water-based mastic, you're going to require a minimum of 48 hours to pressure test the system. If you're using a rolled sealant, they can get done and test immediately. So you're going to choose, so the proper procedure for this, choose that section of duct to be tested. That should be identified for you. Select a test pressure and not in excess of the pressure class rating of the duct. Usually it's the actual operating pressure of that system. You're going to provide temporary seals at the ends of the ductwork because what you're testing is the duct system. Measure the pressure, and then what you're doing is you're putting a amount of air into the duct system to get to a certain amount of pressure. Let's say it's an inch of static, and you're measuring that through an orifice plate on a duct leakage tester. So the amount of airflow flowing through to keep that duct system at 1 inch of water gauge is what's leaking out. Pretty simple. When you're talking about test pressure, and this next slide shows that perfectly, one of the key things as an engineer myself, you always want to test it 2-3 times for a safety factor and all that. But when it comes to ductwork, you need to test to the pressure the ductwork is rated to run at or is actually running at. Because if you do excess pressure, then you can collapse the duct, you can explode the duct, and you're looking at that 2 to 3 safety factor, you'll permanently damage that duct system. And if you're the guy doing the testing, then you're going to also be the one replacing that duct system. All right, so outdoor environment concerns, have typically driven the action plans we all see and analyze how leakage contributes to the consumption of energy. Greenhouse gases, we all understand, as things are running and we're using extra energy and all that, how that impacts. Next slide. When we're talking about energy consumption, the chart on the left shows the industrial sector is the largest consumer of energy. That's including direct fuel use and electricity purchased from the power sector. Chart on the right shows the transportation sector emits more CO2 overall. So moving on from that as well, when we're talking about energy consumption, whether it's renewable or carbon-based, we all understand that duct system needs to be as efficient as possible so that highly efficient unit up on that building can be as efficient as designed as well. Next slide. Building energy codes, commercial, because of safety codes, energy codes, and standards, they're all developed independently, but the most recent addition of a code or standard, we all know here in Texas and Oklahoma, they may have not been adopted by a local jurisdiction. HVAC designers need to know which code compliance obligations affect their designs. Where is this building going? They need to make sure that they're following that. Also if it's an HVAC designer that is going above code, that's also obviously a great thing. But if there's a conflict with a design intent, then they need to resolve that issue with the local building official. On the residential side, same thing here as well. You need to know which code you're trying to be compliant with. We're talking about LEED to LEED V4, and that still says delete on that slide. That's nice. But if you look at that picture, the picture there obviously was maybe from a flood or something like that. But we just need to, make sure that the air inside of that building we know is a direct impact and affect the health of the occupants of the building. And, we need to know that there are no known contaminants at harmful levels within that building, making sure that we have good clean air and that we have, good comfort as well. All right. Improving your indoor environment, just reiterating the message, one of the most important components of specifying and using a quality sealant is just remembering the achievement of good indoor air quality, thermal comfort, fresh air in the occupied building, reducing those potentially harmful emissions. It just makes for more productive people. There's been tons of studies done on that. And typically the topic of air quality really only addressed pollutants in the air outdoors, but facts and statistics show that indoor air quality is more key. Americans, we spend 90% of our time indoors. There's approximately 34.1 million Americans that are living with asthma, and those indoor pollutant levels we know can be 5 to 100 times higher than outdoor. It's easy to understand, when we're comparing to our tight and closed spaces and how we're making our homes and our buildings even tighter and tighter and tighter. But comparing that to the great outdoors when you get out there. Just seeking ways to make sure to address those concerns in a proactive manner and that will benefit both the occupants of the building as well as being eco-friendly. Most of us are aware that healthy levels of VOCs, improper airflow, dirt and dust in the air, that can all trigger issues such as, headaches, upper respiratory conditions, as asthma, allergy attacks. Those all lead to sick days, lower productivity, all that. So the conveyance system, right? That's the problem. It's not just VOCs that are contributing to the unhealthy air. It's improperly sealed duct. We talked about entraining dirt and debris, which produces unhealthy air that can negatively affect the occupants within a building space. And it's also the perfect pathway or conveyance tool to spread that throughout the whole building.
Are those refrigerant and gas lines inside a duct?
We have seen that. Specifically in the Northeast, where you have low-income housing and you have a exhaust shaft that's great for cable, refrigerant, all kinds of stuff. It's a nice pathway from the top to the building to the bottom of the building. So just cleaning and sealing ducts, right? The solution, making sure that if it's an existing system, that you clean it prior to sealing that. If it's a new construction, if you didn't have duct wrap on the ends of that, trying to protect it during the construction phase, cleaning that as well, making sure that it's sealed as well as you can. And just a quote from a gentleman out of South Carolina. He worked on the Duke University chapel, and they were charged with rehabilitating that chapel, the entire HVAC system, as well as 100 feet of indoor ductwork. Actually, the spires that run up on this building are part of the HVAC system. And they realized the importance of thoroughly cleaning in order for the facility to have a healthy and efficient airflow system. And they also knew the value of applying sealing and coating to the duct system, making sure that any dirty air was not being pulled into the duct system, recirculating through the building. And as Henry said, architects and engineers are starting to realize that you can't just replace an air handling unit and not clean the existing ductwork and the air distribution, especially if you put new ductwork downstream. I've seen cases where dirt from old ductwork blew into the new ductwork, and the entire duct system has to be cleaned again. So a couple of case studies as we're wrapping up here. Law and Odor was a historic Oklahoma courthouse. They had a sickening, musting smell, years of recirculating stagnant air. Was due to a failed pneumatic control system, no fresh air. Solution was to install 7 new energy recovery units to bring in fresh air, which required 1,500 feet of new ductwork installed. Additionally, they cleaned and sealed all of the existing ductwork in the building. They used a spray-applied duct sealant from the exterior of the duct due to the challenging access to the ductwork. The ceiling in the courtroom, had beautiful murals on them that could not be disturbed. The contractor was told by the judge that if you put a foot through my ceiling, he would throw him in jail. So anyways, just an example of bringing in additional outdoor air, cleaning that system, sealing that system, and being able to get that indoor air quality back to where it needed to be. Salem Community Hospital. This was a new construction building. Duct sealant was installed and not allowed to cure before install. And also when they made their transverse connections, the butyl gasket on those transverse joints was installed at the very bottom edge, which allowed it to basically squeeze out of that. And when you got into the duct system and looked down the duct system, you could see the butyl sealant hanging. So when they performed the leakage test, many of the joints and seams blew out, causing excessive leakage. Contractor had to turn that building over, but could not until the leakage was within specification. Lower left picture, you can barely make out the ductwork due to the racking system. It was a 20 feet, all 20-foot sections built offsite and installed in 20-foot sections. It just made accessing the system to repair it really challenging. Solution was a robot, which you can see in that lower right picture, and a spray applied sealant to seal the ductwork on the inside. The result achieved about an 85% leakage reduction and allowed the contractor to turn over the building on schedule. And I can tell you that particular contractor, I think, would have given us his firstborn child. Anyways, Parkview Hospital, new construction job with around 32 miles of linear feet of duct, which equated to basically over 100 miles of joints and seams to seal. Since it was a hospital, they wanted to use a product with minimal VOCs that would allow them to meet the tight sealing requirement of 3% leakage. Contractor used a water-based spray-applied duct sealant with minimal VOCs. Our spray seal product, that product allowed them to drive the sealant to the joints and seams, which we talked about because you're using it at high pressure. They were able to meet the sealing spec and be able to be under 3%. And they completed the job in about a fifth of the time that it would have taken them to do a traditional bucket and brush. New Jersey pharmaceutical refit. Was the building over 1 million square feet, almost a quarter-mile long, 3 stories tall. Critical facility as a pharmaceutical. They had a tight ceiling spec, but the contractor was pushing for as close to 0 duct leakage as possible. And the contractor had actually eliminated slip and drive construction from their jobs prior to this due to challenges of sealing those. They would test for leakage multiple times, go fix, find out where the leaks were until the system passed. Spray seal was used on this one as well. The ease of use and sealing capabilities with the spray pump allowed the slip and drive construction to come back in on this job. It was low pressure ductwork. So that was a large cost savings just from the duct construction style. And then when testing for leakage, they only required 1 test, and they were able to meet their criteria. And interestingly enough, on that particular job, most of the sections of duct system that they sealed in there actually had 0 leakage. So just a quick course summary, making sure that you're specifying a sealant and using a sealant that meets the codes. Make sure that you're going to reduce your air leakage. You're going to improve your improve your HVAC efficiency. You're going to promote good indoor air quality. And making sure that you have easy application, you have fast cure time, very low VOC, that you have a UL Green Guard Gold certified product. And if you would go 2 more slides. Thank you, sir. So just a reminder that, if you're designing projects and you're putting sealant specifications in, something like a Green Guard Gold, there's VOC content, which is in the wet state, which is going to be for the contractor, the subcontractor applying the product. And then, of course, there's VOC emissions, which directly affects the building occupants, where Green Guard is specifically the VOC emissions. As we talked about, Green Guard Gold is a recertification program and tests for over 12,000 chemicals. So hopefully we covered everything, and I'll get to the last slide if there were any questions. Also, my contact information, if there's any information you wanted to follow up with or ask separate out of this webinar, please feel free to reach out. You've got my email, my office number, even my cell number. Jason?
I do have just a few questions that have come in, and I think you just answered the one. One was asking about Green Guard. Is it similar to LEED or just a spec? It sounds like it's just an air quality spec and maintenance.
So LEED, so LEED V4 chamber test is a chamber test that talks about the emissions or tests for the emissions of 32 different chemicals, and it's a once and done test. You do it once, and you can, like I said, you can put that in your marketing material for the next 10 to 20 years, where the Green Guard program is a yearly recertification, and they're testing to make sure that the emissions meet requirements for schools, universities, hospitals, that kind of thing. And for example, when you get to Green Guard Gold level, which is they have Green Guard and then Green Guard Gold. Green Guard Gold, they actually do a chamber test as well, but they're testing for over 12,000 chemicals. If you are Green Guard certified on your products, they will come back each year, grab several products, and completely retest them. So LEED V4 is a quick once and done, fairly inexpensive test, where Green Guard is more of an investment and a long-term, if that helps explain that.
Yeah, that can't be cheap to yearly test for 12,000 chemicals. That's got to be fairly cost prohibitive. We got another one. Is it okay to apply liquid mastic over tape?
Over like a rolled mastic sealant, or
I guess just like your typical bucket of Pookie over your typical 181 tape.
Okay, so a 181 tape is actually a sealant. So really putting a bucket and brush over that sealant is essentially you're just doing the work twice. Ideally, if it's outdoor duct work and you're doing a bucket and brush, then you can apply the a 181 tape over that
to help with the UV.
Butyl based, but it gives you that facer gives you UV protection. So, a rolled mastic sealant is a sealant. So you can use that in place of a bucket and brush or in place of a spray applied. And the only place where you really want to use the two together, outdoor duct systems that are going to be exposed to UV, on the coast, those kind of things, where you would do a rolled sealant, and the benefit, or excuse me, you would do a liquid product, which will take care of some of those odd corners and shapes, and then the rolled mastic sealant over that gives you that, as we said, the belt and suspenders approach, and gives you the UV protection.
I recently brushed a bunch over some of the tape seams in my plenum at my house just had busted loose, and rather than try to pull it all off, I just slathered a whole bunch of Pookie all over the top of everything. It worked okay.
Yeah, if we're talking about a UL 181 tape that's an acrylic versus an actual butyl, where that can dry out and come off of the surface, like what you're talking about, that's definitely acceptable. The only concern I would have with that personally is that if that acrylic does come loose, there's a pretty large section of that joint or seam that isn't tightly sealed, right? You can create an air channel through that acrylic if it's lifting off of the surface.
Right.
Gotcha.
Okay, and then I got a couple more. It seems that, obviously most of these examples were commercial. Offering fresh air intakes as a partial remedy to help with IAQ comes with its own issues in Texas, i.e. allergies, contaminants, dust, pollen, etc. Is there a particular article or some sort of guideline or guidance that covers the installation process and procedures for residential fresh air intakes?
Off the top of my head, I do not know of any, but I do have a contact that specifically focuses. It's a company called QFresh, and they make an outside air unit that is supposed to tie in with sensors and all that to the humidity and temperature and all that. If that person that had that question would reach out to me, and I can get them in contact with him, the head guy over there, he should be able to give you, those requirements and how they're doing that, because that company is based, I know it's based here in Dallas. They work all over, of course, Texas, Oklahoma, and outside of there. So he should have what those requirements are.
Yeah, I know. I'm sure Thomas does. I know just from a plumbing standpoint, you've got to be 10 foot away from any plumbing vents for any fresh air intake. I know that's out of the plumbing chapter of the IRC. And
right.
I haven't seen anything that prohibits fresh air intakes being taken from the roof, but just kind of common sense in my mind, and my common sense is occasionally wrong, but do I really want to be taking fresh air from 140-degree black asphalt shingle, or should I run that fresh air intake over to the soffit where it's pulling fresh air from a shaded under part of a soffit? That seems to be like a whole lot better option to me, rather than I always kind of wince when I see those fresh air intakes go into a black architectural shingled roof when they could have just as easily ran it over to the soffit and taken air.
I completely agree with that.
Yeah. And then all these products, all mastic sealants, obviously they'll have ES reports from ICC if you're asked for. You mentioned the UV rating on the liquid mastic. Lots of folks don't realize that insulation at the condenser, or like even on a house, the energy code specifically calls out that that's protected from UV and physical damage. Says tapes are not permitted. But I've told people all the time, or contractors all the time when I made them start protecting that. I was like, a lot of times your mastic has a UV rating and you could use your mastic there.
Yeah. Well, actually, we have a product called TPO line set wrap. And the TPO line set wrap is a TPO roofing membrane, a white TPO roofing membrane that has butyl on the back of that. So it's like similar to a rolled mastic sealant. The challenges we run into is out in California, you have to be able to remove that in order to be able to save the really cheap piece of foam if you're going to do any modification, any work, service work or whatnot. So it has a full release liner on the back of that. So you can either do a fully adhered wrap, or you can do a partially adhered where you're just doing a strip along the edge. But because it's a TPO roofing facer on that, probably 8 to 10 mils thick, it definitely gives the UV protection. It's white, it's a TPO. It's not going to chalk up or anything like that in the sun. Because it is a TPO roofing membrane, it also gives that protection for weed eaters, that kind of thing. As a matter of fact, we brought an electric weed eater into the office to test it. The admin was not so pleased with us, but that's something to look at. It's called TPO line set wrap. And then we also have a product called Seal Tack, which is just a coating. And that gives the UV protection. It does not give, the damage protection from, weed eaters or, lawn equipment or a dog or whatnot. So.
Yeah, I love that we haven't figured out residentially that leaving that little 6-inch strip of dirt in between the condenser and the house so that weeds can grow all up in there and you can't ever, that we haven't figured out to quit doing that. It's kind of funny to me.
Right.
But anyway, that was all the questions. Frank, really enjoyed it. I learned quite a bit this morning. Thanks everyone for joining us. And remember to get your CEUs. Just simply answer the question at the end. You see Frank's contact information here. So I'm sure, as always, after the fact, when the questions come to you, just jot that down. And do you mind if I send a PDF copy of these slides out?
Please do. I do not mind at all, sir.
Okay, so you'll get a copy of the PDF of the slides, everyone, that has Frank's contact information. And again, feel free to reach out to me with any training, and we'll be happy to take care of you. So we're about 9 minutes over. I'll go ahead and stop it here. Thanks for joining us this morning, everyone. And our next one will be on the 6th. Let me double check here to make sure. Yes, our next one will be on February 5th, and it's related to hot water. I don't have a title and description quite yet, but we'll be sending those invites out in about a week and a half. So we'll see you on February 5th. Thanks again for doing that for us this morning, Frank. You guys have a great day. Bye.
Thank you, Jason. Appreciate it, guys.